So hello everyone. In today's session we are going to continue the problems related to the Z-transforms. So let's continue with the problems. So the first problem is Z-transform of n into e power an. So now in this we need to take the e power a. Let's consider the term e power an. We can write e power an as e power a whole power n. Now let's make that e power a whole power n equal to k power n, where k is equal to e power a. Now by using the damping rule, we know that we've used damping rule in many of the problems. Z transform of n into k power n is equal to Z transform of n, where Z is replaced by Z by k. Since in place of a there is k, so we need to replace Z by k. So now let's start with the problem. So we know that the Z transform of n is Z by Z minus 1 whole square. Z is replaced by Z by k. Now replace all the Z by k. So now this becomes Z by k divided by Z by k minus 1 whole square. So further simplifying this, so now let's take the LCM inside the bracket, that is Z minus k by k whole square. So now split the powers inside the bracket. Z minus k whole square divided by k square. Now take the reciprocal. So this k square becomes the numerator, Z minus k whole square. Now cancel one k. So the remaining term is zk divided by Z minus k whole square. So this is the required Z transform of n into k power n. So the problem is not done yet. So now since we have taken k is equal to e power a, so now wherever there is k, we need to replace it by e power a. So now Z into e power a divided by Z minus e power a whole square, that is equal to Z into e power a. Now apply the a minus b whole square property, so it becomes Z square minus e power 2a, so plus e power 2a minus 2z into e power a. So this is the required answer. We will move to the next problem. So this is the next question, that is we need to find the Z transform of n by 3 power n plus 2 power n square plus 4 cos n theta plus 4 power n plus 8. So here in this case we need to take the Z transform separately for each terms, and then we need to the final answer is we need to add all the separated Z transforms that we have taken. So now the first term we need to consider is n by 3 power n. So now bring this 3 power n to the numerator, so this power will change to minus n. So this becomes Z transform of n into 3 power minus n. So now we have a damping rule for this, that is Z transform of n into a power minus n. For that we have one rule, that is, let's use that. Z transform of n into 3 power minus n is equal to Z transform of n, where Z is replaced by 3Z. Here the value of a is 3, right? So we need to replace the value of Z by 3Z. Okay. So now let's apply. So now we know that Z transform of n is Z by Z minus 1 whole square. So now replace the value of Z by 3Z. So the final answer is 3Z by 3Z minus 1 whole square. So now similarly let's consider the second term of this question. Again in this case we need to apply the damping rule once again. So the damping rule says that Z transform of n square, where Z is replaced by Z by 2. The value of a here is 2. A power n square, right? So now we know that the Z transform of n square is Z square plus Z divided by Z minus 1 whole cube. Z is replaced by Z by 2. So now replace all the z by 2. So this becomes z by 2 whole square plus z by 2 divided by z by 2 minus 1 whole cube. So now let's take this square term. So this becomes z square by 4 plus z by 2 divided by, let's take the LCM, z minus 2 by 2 whole cube. Now again apply the LCM in the numerator. So this becomes z square plus 2z by 4 divided by, split the powers, z minus 2 the whole cube divided by 2 cube. So now let's bring this denominator to the numerator by taking its reciprocal, z square plus 2z by 4 into 2 cube divided by z minus 2 whole cube. So this becomes z square plus 2z by 4 into 2 cube is 8 divided by z minus 2 whole cube. So here 4 1s are, 4 2s are. So the final answer is z square plus 2z into 2, right? So we have to multiply 2 to the both the terms. So this becomes 2z square plus 4z divided by z minus 2 whole cube. So this is the required answer for this term. So now let's similarly consider the next term. So in this case we can take this 4 outside. As the linear property says that we can take the constant term outside. And we know the z transform of cos n theta, that is z square minus z cos theta divided by z square minus 2z cos theta plus 1. This is your required. So similarly for the next term, that is z transform of 4 power n. This is the direct z transform of a power n. We know that z transform of a power n is z by z minus a, right? So z transform of 4 power n will be z by z minus 4. So now the remaining term is z transform of 8. So I'll do it here itself. Z transform of 8. Again we can take this 8 outside as a linear property. 8 into z transform of what remains inside? 1. So again we know the z transform of 1, that is 8z divided by z minus 1. So now whatever the answers we have got till now, we need to sum them up to get the final answer. So yeah, this is your required final answer, that is z transform of n. We have separately taken the z transform of all these 5 terms and we have written the answers whatever we have calculated. So this is your required final answer for this question. So now we are going to solve some problems related to the initial value theorems, that is the values for u0, u1, u2 using some of the fractional terms. Okay, so now we'll solve some problems related to that. Okay, so now the question goes like this for this case. If z transform of un or u of z is equal to 2z square plus 3z plus 12 divided by z minus 1 whole to the power 4, then we need to find the values for u1, u2 and u3. So for these u1, u2, u3 up to un, we have written some of the standard formulas in my explanation session. Okay, so using those standard formulas we need to find the values for u1, u2 and u3. Okay, so now we need, since for finding the value for u1 we need to find the value for u0 first. So now we are going to start with u0. So the u0 formula says that we have written it, limit tends from z tending to infinity u of z. Okay, so now write it down, tending to infinity, u of z is 2z square plus 3z plus 12 divided by z minus 1 whole power 4. u naught is equal to limit z tends to infinity. So now we need to take this z square term outside. Okay, let's try to take this z square term outside and let's write the remaining terms. Okay, in the numerator let's take z square outside. So what are the terms remaining? 2 plus, since there is already a z, so in order to, if we take z square outside, the remaining term would be 3 by z. Similarly here only 12 is remaining, so in order, if we take z square outside, so we need to have another z square, so this becomes 12 by z square. And similarly in the new denominator, take z power 4 outside, so the remaining term is 1 minus 1 by z to the power 4. Okay, so now we can cancel this z square and z square, since here, so here z square would remain. So finally let's apply the limit, that is z tending to infinity. Okay, so this becomes 0, so 2 plus 3 by infinity plus 12 by infinity, so infinity square is infinity itself, divided by z square, that is infinity square, into 1 minus 1 by infinity whole to the power 4. 2 plus anything divided by infinity, we know that it is 0. Okay, plus again anything divided by infinity is 0, divided by infinity square. Infinity square is again 0. 1 minus 1 by infinity is again 0 to the power 4. So 2 plus 0 is 2, divided by 1 minus 0 is 1. So this becomes 0. So the final answer for u naught will become as 0. Okay. So similarly now we need to find u1. Now so let's find u1. Z into u of z. So the required u of z is z minus 1 to the power 4 minus u naught, that is 0. Z tending to infinity again. Here let's take z square outside. So if we take z square outside, so z into z square will become z cube. So directly we'll write z cube outside, and again the same thing, 2 plus 3 by z plus 12 by z square, divided by, again in the denominator let's take z power 4 outside, 1 minus 1 by z whole to the power 4. Again by calculating this we get the value of u1 as 0. Okay, since after substituting the limits as infinity everywhere. Okay, now let's find u2. So this is the formula for u2, z square into u of z minus u naught minus u1 z inverse. Okay, so now let's substitute the values. Z square into the u of z is 2z square plus 3z plus 12 divided by z minus 1 whole to the power 4 minus 0 minus u1 into u1 is 0, so u1 0 into z inverse is 0 again, so you can write it as 0. Z tending to infinity. Again let's take z square outside. So since there is a z square outside, so z square into z square would become z to the power 4 into again 2 plus 3z plus 3 by z plus 12 by z square. 0 minus 0 is 0, I'm not going to write that, and again take z power 4 outside in the denominator. 1 minus 1 by z to the power 4. So here we can cancel this z power 4. Okay, so the remaining term is 2 plus 3 by z plus 12 by z square divided by 1 minus 1 by z whole to the power 4. So now let's apply this condition, limit z tending to infinity. So the final answer becomes 2 plus 3 by infinity is 0, 12 by infinity square is again 0, divided by 1 minus 1 by infinity is 0 whole to the power 4. So 2 by 1 minus 0 is 1, 1 to the power 4 is 1. So the required value of u2 is equal to 2. Okay. So now again in the same way we are going to find u3. So now before finding the value for u3, we need to remember this identity, because this identity we are going to use while finding u3. So the identity is a minus b whole to the power 4. That is a power 4 minus 4a cube b plus 6a square b square minus 4a cube b cube plus b power 4. We are going to use this identity, and we are going to expand one term, okay, in order to make the problem easier. Okay, so we are going to use this identity only in case if we are finding u3. Okay, so please make a note of this. So we know that u3 we have defined it, that is z cube into u of z. This z cube remains outside. Okay, this u of z term is there, right? This term that should be in one bracket, and this z cube is separate and separate term outside, so don't merge with this together. Okay, so z cube into u of z minus u0 minus u1 z inverse minus u2 z to the power minus 2. Okay, so now let's simplify. Z cube remains outside. U of z is 2z square plus 3z plus 12 divided by z minus 1 whole to the power 4 minus 0 minus 0 minus 2 by, let's u2 is 2, right, and z to the power minus 2, let's bring it to the denominator, so it becomes 2 by z square. Okay, now we need to take the LCM. Before that, let's write these two terms together. Z minus 1 whole to the power 4 minus 2 by z square. So now let's take the LCM for these two terms, that is, let's first write the denominators by multiplying, and now z square into 2z square plus 3z plus 12 minus 2 into z minus 1 whole to the power 4, right? So now u3 becomes z cube into, z cube is outside, and now let's multiply z square to each of the terms. So it becomes 2z to the power 4 plus 3z cube plus 12z square minus 2 into, now we are going to apply this a minus b whole to the power 4 formula. Okay, we have written it, right? So what does this become? So z a to the power 4, so z to the power 4 plus 4z cube plus 6z square, 6a square b square, right? So it becomes 6z square minus 4ab cube, so 4z plus 1 divided by z square into z minus 1 whole to the power 4. Okay, this z cube is separate. Okay, don't think that it's directly to the denominator. So now let's further simplify this. Z cube into plus 3z cube plus 12z square. So now let's multiply minus 2 to all the terms. It becomes minus 2z to the power 4 minus 8z cube minus 12z square minus into minus plus 8z minus 2 divided by z square into z minus 1 to the power 4. So now we can cancel some of the terms here. 2z to the power 4 gets cancelled, 12z square gets cancelled, and we'll write the remaining terms. So the remaining terms are z cube is outside, 11z cube plus 8z minus 2 divided by z square into z minus 1 whole to the power 4. So now let's again take few terms outside. So this z cube is outside, right? In this term, let's take this z cube outside. So this becomes z cube into z cube, and 11 remains plus 8 by z minus 2 by z square divided by, again in this we will take z to the power 4 outside. Since there is already a z square outside, z square into z to the power 4, 1 minus 1 by z whole to the power 4. So now we can cancel these two terms. Since z cube into z cube is z to the power 6, and also z square into z to the power 4 is z to the power 6. So we can cancel these two terms. So the remaining term is 11 plus 8 by z minus 2 by z square divided by 1 minus 1 by z whole to the power 4. So now again let's apply the limit condition. That is 11 plus 8 by infinity is 0 minus, again this 2 by infinity square is become 0 divided by 1 minus 0 to the power 4. So 11 divided by 1. So the value of u3 which we got is 11. Okay, so now we have found the values for u1, u2 and u3. The value of u1 is 0, u2 is 2 and u3 is 11. Okay, so similar problem we are going to solve. Okay, I'm going to give that problem as homework. Okay, you guys try to solve it. Same type of problem. Okay, yeah, I'll give the question right now. Yeah, so this is your homework, or you can say it as one kind of an assignment. So please try this at home. Okay, the problem is if u of z is equal to, these things change. Denominator remains the same, 2z square plus 5z plus 14 divided by z minus 1 whole to the power 4. In this case we need to find u1, u2 and u3. Okay, I've solved one problem similar to this one. So please refer to that problem and please try to solve this problem. Okay, so this ends your Z transforms. So in the next session you are going to start with the inverse Z transforms. Okay, that's also a simple concept. I am going to explain you in a few minutes in the next session, and we are going to start with the problems. Okay, in the next 2 to 3 sessions we are going to complete this module, that is Z transforms. So this half chapter is completed, the Z transform part is completed. So in the next session we are going to start with the inverse Z transforms. Okay, so yeah, that's all. Thank you.